Hello student, now we'll start the exercise 3.5 for the circular permutation. I had explained all the examples in a very simple language. I hope that you will understood all the problems that I had explained. Now let us start. Now let us start the circular permutation. That is the circular arrangements or permutations are considered different only when the relative order of the object is changed. These are the main points. I think that if you remember this, then you can solve all these exercises. Circular permutation of n objects next point is if the position of any object of n is fixed, if the position of any object of n is fixed up and the remaining objects are arranged in all, this is important formula, in all possible ways, then the number of distinct circular arrangement of n objects is n minus 1 factorial. 1 is fixed, then the arrangement of the remaining is n minus 1 factorial. This is important formula. We use this formula in number of examples, in all examples. Next is if the arrangements are made with respect to table. This is also important. If the arrangements are made with respect to table, then the number of ways in which n objects can be arranged around the circular table is n factorial. Next is circular arrangement can be made clockwise, direction, anti-clockwise direction. Next is clockwise and anti-clockwise are not distinguished The number of distinct circular arrangements or permutations, the number of distinct circular arrangement or the permutation of n object is n minus 1 factorial upon 2. The number of distinct circular arrangement of the permutation of n object is n minus 1 upon n minus 1 factorial upon 2. Next is the number of ways in which n objects of which p are like can be arranged in a circular order where clockwise and anti-clockwise orders are not different is n minus 1 factorial upon p factorial. Now we'll start the exercise, that is a 3.5. In how many different ways can we in how many different ways can 8 friends sit around a table? Here n is equals to 8. The number of ways in which 8 friends can sit around a table is the first formula, that is n minus 1 factorial, that is 8 minus 1 factorial, which is 7 factorial. And we can calculate its value, 7 factorial, that is 5040 ways. Therefore, next is question number 2. A party has 20 participants. Find the number of distinct ways for the host to sit with them around a circular table how many of these ways have two specified persons on either side of the host, on the either side of the host. Now here n is equals to, that is a 20% participant. Find the number of the distinct ways for the host to sit with them. It's very normal. That n is equals to total number of the participant, that is a 20, and 20 plus 1, that is a 21. And now their arrangement, that is we use here the first formula, that is n minus 1 factorial. The number of ways in which these 21 participants can be seated at a circular table is equals to n minus 1 factorial. That is a 21 minus 1 factorial, which is a 20 factorial. Therefore, now taking the two particular persons, that is it, and host as a one unit, therefore 18 plus 1, that is a 20 participant, that is a 2 particular, that will be 18, and that 2 plus 1, that is a 1 unit we consider here, that is 18 plus 1, that is a 19% are here. Therefore, the 19% can be arranged in 19 minus 1 factorial, that is equals to 18 factorial. 18 factorial means the host always occupies the center position, and the two particular persons be seated on either side of the host. In 2 factorial ways. Therefore, the total number of circular arrangements the total number of circular arrangements in which two particular persons be seated on either side of the host, that is equals to 18 factorial into 2 factorial, that is 18 into 2. Now the next is delegate from 20 countries participating a round table discussion. Find the number of sitting, find the number of sitting arrangements where two specified delegates are always together, second, never together. Now we'll find out the 24 participant, that is the delegates, how many times can be they seated around the table. The number of delegates is equals to 24. Therefore, 24 delegates can be seated at the round table in n minus 1 ways, that is the 24 minus 1 ways. Okay. Now we want to consider, that is always two delegates are together. Therefore, consider the two particular delegate. The two particular delegates are together. So we have 22 plus 1. That is the two delegate treated as one unit, and they become 23. Next is now two particular delegate can be seated in 2 factorial ways. And 23 delegates can be seated in 23 minus 1 factorial, that is a 22 factorial, and therefore that is the total number of the weights for the total number of circular arrangement of delegate in which two particular delegates are always together is equals to 22 factorial into 2 factorial. Now the B part is easy one. Now we'll subtract here. That is a never together. That is, first we consider the 24 delegates, and they can be arranged 23 factorial ways. That is a 24 minus 1 factorial. And if we subtract this 22 factorial into 2 factorial, that is all together, then we will get here the number of circular arrangements of delegates in which two particular delegates they were together is equals to total number of the arrangement of the 24 delegates around the table, total number of circular arrangement total number of the circular arrangement of the 24 delegates minus total number of circular arrangement in which that is the two particular delegates are together. We subtract it and you will get are always together. Therefore, 23 factorial minus 22 factorial into 2 factorial. This normal calculation. 23 into 22 factorial minus 22 factorial into 2 factorial. Take 22 factorial as a common. 23 minus 2, then you will get 22 factorial into 21. Now the next is question number 4. Find the number of ways for 15 people to sit around the table so that no two arrangements have the same neighbors. Find the number of ways for the 15 people to sit around the table so that no two arrangements have the same neighbors. Now the number of people n is equals to 15. The number of ways in which 15 per people can sit around a table, that is n minus 1 factorial, that is 15 minus 1 factorial is equals to 14 factorial. The next is any person can have the same neighbors on either side in clockwise or the anti-clockwise. It's clear that if the person is in middle, if you go the clockwise and anti-clockwise, then it has the same neighbors. Clockwise, any person can have the same neighbors on either side in clockwise or the anti-clockwise arrangement. Therefore, the number of ways in which any person shall not have the same neighbors in any two arrangements is equals to n minus 1 factorial upon 2 factorial. That is, these two must be the different one. That is the n minus 1 factorial upon 2 factorial. 15 minus 1, this is also formula. 15 minus 1, that is the 14 factorial upon 2. A committee of 10 members sit around a table. Find the number of arrangements that have the same precedent find the number of arrangements that have the president and the vice president together. That is, from the 10 members, we will take the 2. It is treated as 1 unit. 8 plus 1 is a 9. And in this way, they are together. The number of committee members, n is equals to 10. Consider president and vice president, 1 plus 1, that is equals to 2 as a 1 unit. Next is therefore there are 8 plus 1, that is 9 members, and they can be arranged around the table. That is a 9 minus 1 factorial. They can be arranged around a table. That is equals to such that arrangements 9 minus 1 factorial. Now the sitting of the 2, therefore the corresponding each of these 8 factorial arrangement the president and vice president can be arranged in 2 factorial ways. That is the 2 ways. President and the vice president president and the vice president can be interchanged. Their places in 2 factorial ways. Therefore, the total number of circular arrangements of 10 committee members in which president and vice president sit together is equals to 8 factorial into 2 factorial. Now next is question number 6. 5 men, 2 women and a child sit around a table. Find the number of arrangements where the child is seated between 2 women, second between 2 men. Now first is that is the total is 5 plus 2 plus 1, that is equals to 8. 5 men plus 2 men, that is equals to 8. Next is consider 2 women and a child as a 1 unit. Hence, that is 5 plus 1, that is equals to 6. And now this can be arranged as, that is 6 people are there. Six people can be arranged. That is 6 minus in bracket 6 minus 1 factorial. 6 minus 1 factorial. That is 5 factorial ways. Second, now the child is seated between 2 women two women can be interchanged because only 2 women are there. One will be there, left and right will be there, and sit in 2 factorial ways. Therefore, the number of ways of arranging 8 persons arranging that the child is seated between 2 women is equals to 5 factorial into 2 factorial, and that is equals to 5 into 4 into 3 into 2 into 1 into 2. that is equals to 240. Next, child is between two men. Now the two men can be considered. Two men can be selected from 5 men and can be happen, that is a 5 to 5 ways. That is equals to 5 factorial upon 5 minus 2 factorial, that is a 5 factorial, 4, 3, these two get cancelled, and that is equals to 10. Therefore, 10 ways. Now the group of 2 men and 1 child is treated as 1. Therefore, again same thing is here. Therefore, the 3 men are remaining now, and the women are 2. That is a 3 plus 2, that is a 5, and that 1 unit, 5 plus 1, that will be the 6. This 1 is the group of the 2 men and the 1 child. 3 are the men and the 2 are women, totally 6. And now these persons can be arranged in 6 minus 1 factorial. Now the 6 persons can be arranged in 6 minus 1 factorial is. Therefore, the number of ways arranging 8 persons such that the child is seated between is equals to 10 into 5 factorial into 2, that is a 10 into 10 into 5 into 4 into 3 into 2 into 1 into 2 into 1. Selection of the members, formation of this arrangement, and the 2 persons particularly how they can sit. Next is question number 7. 8 men and 6 women sit around a table. How many of seating arrangement will have no 2 women together? Now the 8 men are there and 6 women. Therefore, the women should not live together. See this here. 8 men and 6 women are sit around a table. Therefore, since no two women together no two women together, first 8 men can be seated in following ways. Now see this here. And the space for the woman is 6. That is 1, 2, 3, 4, 5, 6, 7, and 8. Therefore, now 8 men can be seated around a table. That is 8 minus 1 factorial. That is 7 factorial ways. Next is from figure 6 women can occupy any one of 8 seats. Therefore, 8 P6 ways. That is 8 P6 ways. Hence, the number of ways in which 8 men and 6 women can sit around a table such that no two women are together. That is 7 factorial. 8p6, that is 7 factorial into 8p6 ways. Okay. Next is question number 8. Find the number of seating arrangement of 3 men, 3 women to sit around a table so that exactly 2 women are together Now first is we can select 2 women from 3. In 3 ways. That is first, second, third, and first and third, like this. First, we will allow the seat for the 3 men, and this can be done in 3 minus 1 factorial, that is a 2 factorial ways. That is only the 2 possibilities will be there, left and right. Now these positions are the positions of the woman. Now see this here. There are 3 seats to arrange one group of 2 women and remaining 1 woman that is a 3p2. Therefore, we here treated as 3 seats are available, and the group will be that is a 2 women considered as one group and remaining 1, that is 1 plus 1 is 2 here. This one group is treated as again the 2 factorial ways. Now this is the arrangement of the women sitting. There are the 2 women treated as 1 and remaining 1 is treated as 1, and therefore 1 plus 1 is 2. And they have the 3 places, therefore it is a 3p2 into 2 factorial ways. Now next is a number of ways arranging, that is a 3 men, 3 women is equals to, and the 3 men around a table is equals to such that exactly 2 ladies, that is 2 women sit together. Therefore, the number of ways for the is 2 factorial, and next is a 3p2 into 2 factorial. That is equals to 3 into 2 factorial into 3p2 into 2 factorial. Therefore, this is the 3 groups of the women can be formed. The That is, we will see again that we will see this here. 3 into 2 factorial plus 3p2 into 2 factorial. This is for the women, and two women can be selected in the three ways. In 2 persons, 2 men can be arranged in 2 factorial. In this way, 3 into 2 factorial into 3p2 into 2 factorial. Now we'll perform the multiplication. That is a 3 into 2 factorial, 3p2 into 2 factorial. That is 3 into 2 into 3 into 2. Therefore, their multiplication is 72. Next problem, problem number 9. 4 objects in a set of 10 objects are alike. Four objects in a set of the 10 objects are alike. Find the number of ways of arranging them in a circular order. Then that is n is equals to 10, p is equals to 4. Therefore, by using the formula, therefore number of ways in which 10 objects of which 4 are alike. That is a 10 minus 1 factorial upon 4 factorial. Can 4 are alike can be arranged in a circular order, n minus 1 factorial upon p factorial. That is a 10 minus 1 factorial upon 4 factorial. 9 factorial upon 4 factorial. 9 into 8 into 7 into 6 into 5 into 4 factorial. These two get cancelled. We can perform the calculations. The multiplication is very normal. That is a 15,120. Now the question number 10. 15 persons sit around a table. Find the number of arrangement. Find the number of that have two specified persons, not. That is the problem, is the 15 persons sit around a table. Therefore, here n is equals to 15. 15 persons are arranged around the table in 15 minus 1 factorial. That is a 14 factorial. 14 factorial ways. Two particular persons sit together, that is a two particular person treated as one unit, that is a 13 plus 1, that is equals to 14. Therefore, the number of ways in which in which 15 persons are arranged around the table such that two particular persons sit together, that is, these 14 can be arranged around the table in 14 factorial. 14 minus 1 factorial, that is a 13 factorial. Therefore, that is equals to 13 factorial into 2 factorial. Therefore, the number of ways in which 15 persons are arranged around the table such that two particular persons are not together, not sitting side by side, is equals to 14 factorial minus 13 factorial into 2 factorial. Now the simple calculation is here. 14 into 13, that is 13 factorial as a common, then you will get 14 minus 2, and that is equals to 13 factorial into 12. And in this way we have completed the exercise 3.5. I hope that you will have understood all the problems. I'll see you in the next video. Till then, goodbye. In this way, the exercise 3.5 is completed. I hope that you will have understood all the problems, whatever that I had explained. Now we'll see in the next video. Till then, goodbye.